So if I give you a constant function like f of x is equal to 5 or some constant, I'll do an example. Y equals 3 is a constant function. Yesterday we learned about the graph of y is equal to 3. Is that a horizontal line or a vertical line? Do you remember? Let's pick a spot where it has a y value of 3. Does this coordinate have a y value of 3? Does this coordinate have a y value of 3? So is that going to make a horizontal line or a vertical line? It's going to make a horizontal line. This is something you've learned before. Oh, you got it, bud? You're looking for it. That's on the study guide. You're going to need your notes. Linear function is f of x is equal to x. Okay? And that parent function looks like this. Now, what we learned yesterday is that you can change the way that a linear function looks by putting a slope in front of it or by adding on to it a y-intercept or something of that regard, okay? An absolute value function, a little bit different. If you want to see the absolute value of x, absolute value makes everything what? Positive. So it's very similar to this, isn't it? But it makes it positive. So this part that dips below the y-axis, it's going to go back up. And so it's the same type of graph. It just makes those values that were negative, it flips them up and makes them positive. You need to have a visual representation in your mind of what all these are. My guess is you know the constant one, don't you? And you know the linear one. But absolute value of x, that might be one that you've forgotten over the years. Okay? So let's move on to the next one. Quadratic. Suppose we have an x squared. Anybody remember what the shape of an x squared looks like? It's a parabola. And so this parabola will be centered at 0, 0 and look like that. All these graphs you looked at last year within Algebra 2, and you even looked at the cubic function as well. Not much, but a little bit. And a cubic function is just slightly different than the quadratic. It comes down like this, but instead of going back up, it drops back through to the other side. And our last example would be the square root function, or the square root of x. Can you take the square root of negative numbers? No. So as you look at this, you can tell that it doesn't go over to the negative side at all. Okay, there are no square root of negatives. Okay. This is our library of functions. You need to remember what shape they make. If you want to refer back to it, you can, but you don't get this sheet of notes on the test. My guess is you already know the first one, the second one, and the fourth one. Maybe what's new to you would be absolute value, cubic, and square root. And some of you remember them all. So let's flip over the back side, and let's sketch a graph of these, okay? And we'll describe the transformation. First of all, what's the parent function? Yeah, it's like a v, right? The absolute value function, right? So the parent function, if you want to write it down, is the absolute value of x. Now the question is, what happens after that? You see this x minus 2 on the inside, okay? I'm going to take my calculator, I'm actually going to graph it, and you tell me what happens to this shape. So if I look at my first example, y equals, and I type in the absolute value of x, And then this one, I'm going to type in the absolute value of x minus 2. And I'll make the second one, or the first one bold so it stands out. Tell me how the second is different than the first. Shifted 2 units to the right. There we go. So your new graph is shifted 2 units to the right. So I just drew 2 so that you could see the parent function and the adjusted one. You don't have to do that on your assignment, no. Okay? Here's what's important to remember. You can write this down up above. Inside is a horizontal shift. Outside is a vertical shift. So as you look at the x minus 2, is the minus 2 on the inside of the absolute value or on the outside? It's on the inside, right? And that will create a horizontal shift. The plus 5, is that on the inside of the squared or outside of the squared? It's on the outside of the squared. So therefore, it will be a vertical shift. So our parent function, x squared, looks like this. Most everybody knows that. But then what are the two things that make this different from the x squared? The two things that make this different than x squared. The plus 5 and the what else? The negative. So the plus 5 will move it up 5 units. 1, 2, 3, 4, 5. What do you think the negative in front does to it? Do you remember? It creates a vertical flip. It flips it upside down. So if you see a negative out front, it will take that graph and it will flip it upside down. So you can see that the plus 5 moves it up, and then the negative flips it upside down. So these two examples will serve as a basis for our next two to kind of try to tie our learning together. Notice it was a minus 2 on the inside. It shifts it 2 to the right, opposite of what you think. When it's on the outside, it does exactly what you think. It moves it up 5. So if it's on the inside, you got to think backwards. On the outside, you do it exactly what you're supposed to. So let's apply that to these next two. We have y equals the square root of x minus 3 minus 3. Who can tell me what does the graph look like of the parent function square root of x? Make a symbol with your hand. Very good. So here's what the parent function looks like. So that's what has to start in your brain come the test on Friday. You have to memorize that. That's what that one looks like. Now, I'm going to make 1, 2, 3, 1, 2, 3 in each direction here. Okay. The first minus 3, is that on the inside or the outside? Inside. So will that shift it horizontally or vertically? Inside is horizontal. So is it going to shift it 3 to the right or 3 to the left? Remember which? 3 to the right. It's opposite what you think. Okay? So it's going to go 3 to the right. Then, this second minus 3, is that on the outside or inside? Outside. And so is it going to shift it 3 up or 3 down? Down 3. So this is a shift to the right 3 due to the x minus 3 on the inside, and it's a shift down 3 on the outside. The up and down is always easy to remember, isn't it? This is exactly what you think. You know how I remember the inside? I think of what number would you plug in to make 0? What number would you plug in for x to make the inside 0? You'd plug in 3, right? So it shifted over 3. Kind of like this one here. You'd plug in 2 to make it 0, so it moves 2. Let's look at the last one. What's the parent function? Which shape is this going to look like? Yep, a U or a parabola. So y equals x squared. So as I draw my graph, I'm going to make my parabola shape. Is there something on the inside that will shift this? What's on the inside? The plus 3. Well, the plus 3 shifted 3 to the right or 3 to the left? 3 to the left. Very good. So we'll go 3 to the left. How about the 2 on the outside? Will that shift it up 2 or down 2? Up 2. How about the negative on the outside? Will that make it go right side up or upside down? Upside down. And so this is the function. We're going to try 4 problems from your assignment to get them out of the way, but this is our topic. This is what we have to be able to master and learn together. Okay. All right, let's glance at the second one. Okay, right here. What's the parent function look like? Parabola. Is the plus 2 on the inside or outside? It's on the inside, so will that affect it horizontally or vertically? Horizontally, so will it be 2 to the right or 2 to the left? 2 to the left, opposite of what you think. Very good. You can see the type of thought process we go through every time. Okay, let's try another one. Let's try this one right here, the square root. Hopefully you have memorized that the square root function looks like this. Is the minus 2 on the inside or outside? Inside, so we'll move it to the horizontal or vertical? Horizontal, and we'll move it right or left? Move it to the right 2 units. Let's flip it over the other side. Let's try this one right here. What's the parent function of a cubic look like? Kind of like an S. It's interesting you say that because one of my calculus students lately made fun of me for calling that an S. So, but I agree. I think it looks kind of like an S. All right, so that's the parent function. So you tell me, how many different transformations do I have going on here? Do I have 1, 2, 3, or 4? How many do I have? I have 3 transformations. Let's focus on the horizontal one. How many units do I move to the right or left? 1 unit. Is that to the right or is it to the left? It's 1 unit to the left due to the plus 1 on the inside. So I'm just going to put a little dot, 1 to the left. How about the minus 4 on the outside? What's that going to do? It's going to move it down 4. What about the negative on the outside? It's going to make it do a vertical flip. So that means instead of starting down and finishing up, it will start up and finish down through that spot that we moved it. So you can see I moved it back 1 and down 4. Instead of starting down and finishing up through that spot, I started up and finished down through that spot. Okay. And let's do one more together. Let's do this one right over here. How many different transformations do I have here? 3. Okay. Absolute value function looks like a V. This is very similar to the last one, isn't it? Horizontal is going to be to the which direction? To the left, 1 unit, down 4, and the negative is going to make it flip upside down. So instead of starting up and finishing up, you'll start down and finish down. And if you can make that type of transformation to each function, you should be good to go. This is your task for today. That's it. You have, I guess I told the story at the beginning. And we did a checkpoint. That all took time, 15 minutes of instruction. I honestly think you have a good shot at finishing this within the 10 minutes. Shouldn't take you too long.